Hello to all the Form 5 students. Today I would like to start with a new chapter which is Matrices. Okay, chapter 2 Matrices. So this topic is actually very important. So what will you learn in this topic is of course matrices, and then you learn matrices and also basic operation on matrices. Basic operation means plus, minus, multiplication or division. Okay, why study this chapter? Matrices are used in the field of mathematics to represent and solve problems in algebra, right? So, especially statistics and geometry, right? Okay, in our daily life, it can be used by a purchasing manager to record the amount of inventory in his business. Now, do you know Arthur Kelly was an English mathematician who developed the theory of matrices from the aspect of algebra in his work, A Memoir on the Theory of Matrices. Kelly created matrices when he was researching the theory of transformation. So it's actually got the connection with the transformation. Alright, so there are two American mathematicians, Benjamin Peirce and Charles S. Peirce, worked together with the Kelly in the development of algebraic matrices. Now, for this topic, the most important keywords that you must master are, there are so many important keywords. Matrix, of course, one of them. Row matrix, identity matrix, column matrix, square matrix, rectangular matrix, zero matrix, inverse matrix, scalar multiplication, determinant, order, and element. So all these are important keywords in this topic. Now let's proceed to the story about the matrix. Why is matrix so important? Let's go through together. Alright, so according to Digital Report 2018, the total number of internet user, the total number of internet user has reached 25.08 million people. It's actually 79% the residents in Malaysia. But I think now it should be almost 90% because everyone is online. Everyone is using handphone, laptop, and internet. So the internet user, I think, is more than 25.08 million. Nowadays, the society prefer to carry out daily activities such as shopping and making payment for services through internet, right? Example, you have Grab food, you have Grab food, and then Grab car, you have everything Grab, right? So data is created in this process, support the growth of big data. So the everything through internet, so the data in the computer become bigger and bigger. So big data, what it means by big data. Big data refer to data that is very large, complex, and difficult to process with regular database management. So this set of data can help the management teams in various fields to make better decisions. In the business field, big data is analyzed to reduce costs and time, develop new products, and strategize business plans. And the process of data analysis largely involve matrices. So see that matrices is very important because the process of data analysis involve matrices. Now, how to represent the information from real situation? So we want to convert the real problem into the form of matrices. Okay, let's study the Kedai Electric Sina Jaya records the sales 3 types of fans in a spreadsheet. Spreadsheet is just like Excel. Okay, the diagram below shows the in-store and online sales of the fans for the month of March to May. Okay, so everyone start to buy online. We have Shopee, right? We have many type of the online business, right? Now you see the sales of the fan. Let's see. This is for the March, right? This is for March. Let me highlight to you. This is for March. Oh, that's so thick, huh? Let me reduce the thickness. Okay, for March we have the fan. We have how many type? We have stand fan, ceiling one, and a wall fan. There are 3 types. In store and online. We have the 2 type of purchase, either in store or online. So this is sales of the fans in April. So it seems like stand increase, ceiling 15 and wall 9, and stand 7, ceiling 12 and wall 5. So when come to the total sales in March and April, we will add, isn't it? We will just plus according to the stand fan and stand fan. 16 plus 20, we got 36, right? Okay, we can just add them. And let's say for ceiling, we use the purple one to identify. Ceiling got 18 plus 15, 33, right? So we plus the 2. And finally, we plus the wall fan. The wall fan, we have the how many? We have the 11, right? We have 11. Okay, 11 here, and then we have 9 here. So when you plus, you will get 20, right? So if you want to add like this, refer one by one. It's very troublesome, isn't it? So now the data of the month of the March is represented in the form of table. It's a bit tedious for us. It can also be represented in the form of matrix, right? Now we want to convert the table into matrix. So if you want to convert the table to matrix, we focus on the number of row. So this is called row 1, and this is called row 2. We just focus on the data. We have 2 rows, right? Row 1 and row 2. And then for the column, okay, we have how many columns? Let's see, we have how many columns? This is called column 1. Okay, this is column 2. This is column 3, right? So now we want to convert to row and column. So we will transfer as row and column. Always start with a row followed by column. So we have 16, 18, 11, right? 16, 18, 11, 5, 10, and 4. second row. Alright, so this is called column number 1, column number 2, and column number 3, and this is called row 1 and this is row 2. Okay, so what is matrix then? A matrix is a set of numbers arranged in rows and columns R and C to form a rectangular or square array. Okay, so you can either use the rectangular or square array, depends on the table. Now a matrix is usually represented by a big capital letter and written in the bracket. We have two types of bracket, either you use rectangle bracket or you use the oval shape bracket. Okay, got it? So that means matrix is actually originated from data from the table, right? So let's see, matrix form. Historical treasure. Who is this? James Joseph Sylvester was the first mathematician that used the term matrix. So we must say thank you to James Joseph Sylvester. Alright, so let's go to the next one. Now, example 1. Represent the following information in the form of matrices. Okay, the table below shows the recommended daily calorie intake for females by category. So we have the child, the calorie intake 1,700 because child is still small. Teenager is 2,100. Adult is 2,000 and senior citizen 1,800. So that means teenager like you actually need more calorie intake. For female, this is for female. Okay, the table below show the medal collection of Malaysian contingent for 3 events in 29th SEA Games. So from this table we actually can see different type of the different type of events, and actually the medal also different. We got gold, silver and bronze, and we have the data. So we can actually in fact use a matrix to form the to represent the table, right? So how to represent the data using matrix? So we can just write like this. So it's quite simple in fact, right? So you can actually just use a oval shape. So make sure you write nicely in order, and then make sure you can have the space for the data, right? You have row 1 only, right? You have row 1 and then you have 4 columns for that one. And this one, if I want to convert to matrix, it will be something like this, right? And then I take out the line. So I just write 13, 5, 1, 10, 2, 4, and 8, 8, 9. So I have 3 rows and then 3 columns. So we always write the order of matrix. Okay, for this one in test 1, okay, Samad score 76 mark for BM, 82 mark for mathematics. So BM 76 marks. So Bahasa Melayu 82, uh, 76 for Bahasa Melayu, and then 82 marks for mathematics. Sorry. So we write in order first. So that means for Bahasa Melayu is 76, for Maths is 82, so higher, and history 72 again. Wow, Hamid, we have Samad and Hamid, right? So you can draw you can draw a table first like this. Then from table, then you convert to matrix. Then Hamid score 80 marks for Bahasa Melayu, 88 for Maths, and then 70 marks for History. So you can write like this. You can convert to 76, 80, 82, 88, and 77 and 70 like this. Okay, it depends on your table, how you draw the table. If you draw horizontal, then you get horizontal. So these are the answer after you convert to matrix. So this is the first one. We just have row 1. Okay, and this one is just now the you can do like this. Either is horizontal or the vertical. So this is actually column 1 and 4 row. So we say 4 by 1. This is 1 by 4. So this is a row matrix. A row matrix has only one row. So this is called row matrix. Only one row, right? And then if you have a column, one column, so this is called column matrix, because a column matrix has only one column, right? So we have two ways to write. And for this one, we can write like this. It depends on how your table. So you can either write row 1, row 2. Okay, row 1, row 2, row 3, and column 1, column 2, and column 3. So okay, we have actually 3 by 3 row and 3 column. So this is so-called square matrix. A square matrix has the same number of rows and column. Rows is 3, number of row, number of column is 3. They are the same. So if you have more than one matrix, we call matrices. If one matrix, we call matrix, right? So for C, we can actually write in this way. We have actually 3 row and 2 column, or you can write as 2 row, 3 column. So these are rectangular matrices. A rectangular matrix has different number of rows and column, right? Okay, so now we proceed to exercise self-practice 2.1a. So this is quite simple, so you can try on your own. A fifth generation 5G mobile technology, okay, exhibition is attended. Nice 5G. Alright, by 857 teenager, 3180 adult, and 211 senior citizen. So it's just so simple. So make sure you have the space here. Okay, don't too close. Okay, you can actually represent by a capital letter. Let's say this is fifth generation of mobile technology. You can just use M. Up to you. You can use a big letter to represent the matrix. Now the table on the right shows the average air pollution index (API), air pollution index, in Putrajaya, Jerantut, and Sandakan for 3 days. Represent the information in matrix. So it's quite simple, right? So how you convert to matrix is you just write the matrix in bracket like this. Make sure you write the number nicely in order. Okay, so normally you must leave some space for the data so that it won't be so close like this. 50, 20, and 46. So actually this is a square matrix, right? It's 3 by 3. So it's very simple, isn't it? Right, so matrix is simple. So everyone can do well for matrix. Okay, for number 3, I want you to do on your own. So this is your own homework. So actually I want you to do 1, 2, 3 in the book B. Okay, you have book B, right? So you do the 3 question in the book B, and then we will actually learn how to identify the elements in the matrix. So the elements means that, okay, we see this table first. We have order of matrix, right? Order. You know order of matrix? The order of matrix can be determined by counting number of rows followed by number of columns, right? So let's see this one. What is the order? So first of all, we give priority to row 1, row 2. We have 2 rows, right? And we have 3 columns, so it's 2 by 3. This is called order of the matrix. So the matrix has 2 rows and 3 columns. Therefore, a matrix with order 2 by 3. You read is 2 by 3, not 2 times 3, right? Okay, so matrix with m order, and matrix with m rows and n column. Its order is actually multiply, but we read as by. Okay, we don't read as multiply. By m by n, 2 by 3. Okay, so every number in the matrix is known as element. Example, we have element 5 here. Okay, for example, the element in the second row and third column. So this is row 1, this is row 2. So this is column, I just use a line. This is the line I use, hold on. The row I use green, and the column I use red. Column 1, column 2, column 3. So the 4 is at row 2, column 3. So when we say second row and third column, that is actually the location or the position of the 4. So we can say that if let's say that matrix is big letter A, so big letter A, so when I want to find the element, I will actually use a small letter. So I will say A 2, 3. Lower a bit is 4. A, let's say 1, first row, first column, 1, 1 is 16. Alright, so if I say A 2, 2, it means row 2 and column 2. Alright, so how you read out the row 2? This is row 1, row 2, and then column 1, column 2. So this is the answer for the element in row 2, column 2 is 10. Okay, in general, the element of the I row and J column, we write as A, I row and J column. Okay, so this is just a symbol. So as you can see, the elements can be called by A11 means row 1, column 1. This is row 1, column 2, and so on and so forth, column n. So if you have m row and m first followed by the column at the second letter. Okay, that is so-called element of the matrix. So it's quite simple, isn't it? So for example, let's say this one, we have the matrix, right? The first row and the third column of the matrix P. So we will write like this: first row and third column. So this is equal to 9, right? Isn't it easy? Okay, let's say for matrix Q, 2, 1, row 1, row 2, 2, first column, so it's 5, right? And for 3 is third row, 1, 2, 3, third row and fourth column, 1, 2, 3, 4. So this is the answer, which is 1. Easy? Right. So okay, we have 9, 5, 1, And how about the order of matrix? Yeah, I missed out. Order of matrix is very simple. We just count how many row and how many column. Okay, for example, this one is just one row, so the order for matrix P is actually 1 row and 3 column, 1 by 3. Alright, so for this one we have 1 2 row and 1 column, 2 by 1. For this one we have 1 2 3 4 4 row and we have 4 column, so it's 4 by 4. So that's so called the order of the matrix. So you just count how many row and how many columns. Always call the row first followed by column. So example, this one we have how many what's the order for the matrix D? So row 1, row 2, row 3, right? And then column, we have how many column? Column is actually the vertical, right? Row is horizontal. So we have 3 by 2, right? So the order of matrix is 3 by 2. And the elements of D1, 1, so this is matrix D, so we use a small letter. 1, 1 is -2. 2, 1, so this is row 2 and first column, so it's 0, right? Okay. And then D3, 2. 3, 2 means that this one, right? It's 9. So the element at the third row and second column, 3, 2. Easy, right? Okay. So it seems like it's quite easy. Okay, let's see this one. This is the who introduced brackets for matrix in 1913. So that's the way to write the matrix. This is the scientist or mathematician's name, so you can go through if you want. Alright, so so I have discussed the order of the matrix. I have discussed the elements of the matrix, so I'm sure you can do it. It's quite simple, so I don't think I need to discuss. So you do this one in your exercise book, alright, for 1 to 4 in your book B. Okay, so that's all for today's class. We'll continue to more challenging matrix operation. That's all for today. Bye bye and have a nice day.